Hello dear student, this is Devang Shah from LG Institute of Engineering and Technology under the LG University. So far we learn about the mean terms, max term, literals, the terminology of SOP, POS and how we can utilize those parameters while using the K-map. Now K-map is one of the method to reduce the Boolean functions. By that way you can reduce the digital gates, right? So once you reduce the digital gates, that means you can realize the same output of any complex Boolean function or any complex Boolean equation into very simplified way. So here we are going to talk about the different methods of reduction of Boolean functions, right? So earlier we have discussed about the Boolean algebra where we have reduced the functions, right? So by that way we have reduced the logic gates. Then one more method we have discussed during our previous session, that is called the Carnot map, right? Now same way we can also learn more methods to reduce the Boolean functions, right? And one of the method is called tabulation method, or it is called Quine-McCluskey method, right? What is Quine-McCluskey method? In another sense it is called the tabulation method, where this is also a method of minimization where we are going to reduce the Boolean functions, right? So here two-step process we are going to utilize for in a tabular way. One is the identifying the minimal pi set, that is nothing but we are making the groups of ones, starting from any group which is having no ones, any group which is having one number of ones, any group which is having two number of ones, and likewise, right? And then we are going to sort it out the prime implicants from this tabulation method. So this is two-step tabulation method. All work is done in a tabular form, so you must have to follow a specific table to reduce the Boolean functions. So number of variables is not a limitation here, so you can go up to 3 literals, 4 literals, 5 literals, and so on, right? So there are certain limitations of Boolean algebra where you cannot go beyond 3 or 4 literals. If you going to consider 5 literals, there are 32 different mean terms, and that you have to reduce, which is again a tough task. Same way in a K-map you can maximum go up to 4 to 5 literals, but beyond that there is a problem. But in a tabulation method there is no limitation of variables where you can go maximum number of variables. Then basis of many computer implementations we are using this tabulation method, and don't care are easily handled. So in some of the condition we define as a don't care, but as such this is not covered in our syllabus of the don't care. We are not discussing that don't care condition. So proper organization and term identification are key factors for the correct result. So if we further discuss about this particular method, we can discuss like sorting to reduce the comparison. So sort into group according to the number of ones. So if we define a specific Boolean function here where f of a, b, c, d, which is given in terms of mean terms 1, 2, 3, 7, 9, 10, 11, 13, and 15, right? So as such this method is different from the Boolean algebra. This method is different from the K-map. Here we are using a specific table to define this method. So you can see this is a group number 1 where I have taken number of ones in a sequence. So this number of ones in a sequence and having the mean terms of 1 and 2, both this sequence you can check the 1, the sequence of 4 bits is like 0 0 0 1, and 2, the sequences of 4 bits is like 0 0 1 0. Both these numbers are having the 1 1 1 1 in a sequence, right? Same way group number 2 you can observe the mean terms 3 9 and 10 having the 2 number of ones in a sequence, right? So the earlier group having 1 in a sequence, 1 number of ones in a sequence. In group number 2 having 2 ones in a sequence, you can check 3 is 0 0 1 1, 9 is 1 0 0 1, and 10 is 1 0 1 0. Group number 3, see again here from the mean terms 7 11 and 13 all are having 3 number of ones in a sequence. So 7 is 0 1 1 1, 13 is 1 1 0 1, and 11 is 1 0 1 1, right? So here this group number 3 is having 3 number of ones in a sequence, and group number 4 is having 4 number of ones in a sequence. Now this is, you have to arrange in a table. That's why this is a kind of tabulation method, right? From that, now what I'm going to do, I'm going to now compare here 1 with a 3, right? So I'm going to compare the sequence of 0001 with 0011. There is only a change of one bit, so that comparison is very easy. Corresponding similar bit, if you are going to have, you just put it at a dash here. So from 0001 to, you are going to compare 1 with 3, same way 1 with 9, right? But not 1 with the 10, because the difference is a 9, and see, our difference is always is from 1 to 4 8 in that way. So from that, see, this is what, once you short it out, and you can follow like this way. Now this is one more example how you can just put that particular way. Again, the reduction of this comparison, where short this groups accordance with the number of ones. So you have a function of 1 2 3 7 9 10 11 13 and 15. You put 1 2 3 9 10 7 11 13 and 5, and last one is the 15, right? So here you are going to compare with 1 with the 3, so the difference is 2. 1 with the 9, difference is 8, but not possible with the 1 and 10, because the difference is 9. So our difference is always 2 raised to 0 means 1, 2 raised to 1 means 2, 2 raised to 2 means 4, 2 raised to 3 means 8. Like that way we got the difference. So here 1 2 3, and check which particular bit is going to be changed. If you are going to compare here 1 with the 3, you check the third number of bit is going to be changed from 0 to 1. So you can put in a second table, it's the 0 0 dash and 1, right? Same way from 1 you compare with the 9, see, the 0 and 1 is going to be changed, so the number is dash 001. Then again you are going to compare with first group with the second, like 2 to 3, so the difference is 1, so it's a 001 and dash, and then 2 to 10 is dash 010. By that way, see, in a second table your group now is making of having the 1 comma 3, 1 comma 9, 2 comma 3 and 2 comma 9, right? By that way you must have to do the comparison of group number 1 with 2, 2 with 3, 3 with 4, and in second table you have to sort it out. So from group number 2 to group number 3, in column number 1 you can check 3 with the 7 possible, yes, because the difference is 4. 3 with 11, yes, because difference is 8. 3 with 13, not possible, because that's the difference of 10. By that way, if you are going to see where is the bit difference, and wherever you will find the bit difference, you just put your sequence. So from 3 to 7, the group number 2 to group number 3, 3 comma 7, see, there is only one bit change, which is the second one is the 0 dash 11. 3 to 11 dash 011, 9 11 10 dash 1, 9 13 1 dash 01, and 10 11 is 101 dash. By that way, group number 3 to group number 4, so 7 and 15 possible, yes, because the difference is 8. 11 to 15 possible, yes, because difference of 4, and 13 to 15 possible, yes, because of the difference of 2. So by that way you can also make your correction like that way. Now whatever terms you are going to use, just put it in a mark, so you should understand this particular term. You can not going to put it as a forward in a next column. So now you can check the column number 3 where more difference is possible, yes, from column number 2, now group number 1 2 and 3. So now you are going to compare with group number 1 to 2 and 2 to 3, and correspondingly you have to find the difference of 2 raised to 0, 2 raised to 1, 2 raised to 2, 2 raised to 3, likewise. So from that you will have in column number 3 there are two more groups, 1 3 9 11. So my answer is dash 0 dash 1, 2 3 10 11, so dash 0 dash 1. Again in group number 2, column number 3, 3 7 11 15 and 9 11 13 and 15. So it's a dash dash 1 1 and 1 dash dash 1, right? Again further possible, so you again need to check here if this is possible, then you can go forward, right? So again, by making this dash 0 dash 1, see, you are going to reduce the number of literals, you are going to reduce the number of boolean terms, right? So from that, if you are further going and find the prime implicants, what is the prime implicants is nothing but the rest of the terms you will find. So you can put it like it's a 1 3 9 11, so you can put it like 1 3 9 11, then 2 3 10 11, 3 7 11 15, and 9 11 13 and 15. You can put all the corresponding crosses in between all the mean terms, and you can find it out from that. If those who are having the single cross, those are called the prime implicants. Means without this particular boolean function is not possible. These are called the prime implicants. That means they are compulsory boolean functions that you have to incorporate. So from that you can be able to find f. See, indicates an essential prime indicates it's like 2, which is 2 is like is the kind of b dash into c, because this sequence is available in a table number 3, and second one 2 3 10 and 11. Why it is? Because here the 2 crash is only 1, right? So this is what the term is, where you can find the prime implicants are b dash into c plus c into d plus a into d, right? Those are having the 13 here, so 2 and 13 both are having the single cross. That's why these are called the compulsory prime implicants or essential prime implicants. By that way you can be able to write f is equal to b dash c plus cd plus ad, right? Further, one more example we are going to discuss, that again reduction of this f of abcd, where you will have the number of mean terms is like 0 1 2 3 5 7 8 10 11 12 13 and 15. Again, you use the kind of tabulation method. You go for the first list in a table number 1, second list in a table number 2, and third list in a table number 3. So from that a b c d, you will have a group of no ones, then group of one ones, group of two ones, group of three ones, and group of four ones, right? By that way you can check, and you can always have a difference from group number 1 to 2, 2 to 3, 3 to 4, and 4 to 5 likewise. So whatever terms here you are going to use it, just mark it as a correct one. So just mark it, so you cannot utilize further. So as per the second list, you can check further reduction is possible. Yes, because you must have the difference of 0 2 4 8 16, like that way. So with this you can again in second list you have a comparison of group number 1 with 2, 2 with 3, and 3 with 4. Again you can carry forward this difference, having the 1 bit change value. You can have the third list. From third list, how many implicants you are going to find, and those implicants are from the second table. Those implicants are not being utilized. 8 comma 12 is a into c bar into d bar, and 12 and 13 is a into b into c bar. Same way for third list. See, most of the implicants are, we are not going to use it, which are a bar into b bar, b bar into d bar, a bar into d, and b into d. So you can have your final answer with all the in form of the mean terms is a bar into b bar plus b bar into d bar plus a bar into d plus b into d plus a into c bar into d bar plus a into b into c bar. Again you can go for the prime implicants table, make the cross method, and again you can reduce this following functions, right? So this is about the tabulation method, when you can have a more number of literals, you can have a more number of variables. You can use those kind of tabulation method, and you can reduce the boolean functions. Thank you very much, dear students. So this is one of the method to just reduce the boolean functions. Thank you very much.